Brilliant. Alright, just a real quick one today, gentlemen. Want to take a moment to talk about the Marconi 2955 radio test set. It's been a little while since I've uploaded. Lots happened, mostly moving to a new home in Colorado Springs. So, still kind of a mess in here. Don't even really have all my ham equipment set up yet, but nonetheless, I wanted to get one piece of junk out of my way, mainly this thing, by means of finally fixing it. And as you can see, and I'm extremely happy to tell you, today was finally that day. I've had this thing probably since about 2017, I think. I bought it when I was still working at CI for $300 off eBay as a non-functional unit, in the hopes that I would have the wherewithal to fix it. That was definitely a little bit overzealous, coming from sophomore me. But now that it's almost 5 years later, I've finally been able to do it. So anyway, now that I've said all that, in case you're not familiar with what the Marconi 2955 is, it's a radio test set. So basically it's like a signal generator, a receiver, frequency counter, modulation tester, everything you need to test and align radio equipment in one box. So this is very useful for someone like myself, or probably any ham that dabbles with their electronics, because it allows you to actually, test and fix your stuff when it doesn't work so well, or if you're just curious. And so when I got this, the transmitter, the signal generator portion on it was out. But the receiver worked just fine, and it actually has a really accurate 10 megahertz clock in it. So it was really useful to me as just a receiver and power meter. But I wanted to have access to that signal generator so that I could finally test the sensitivity of my receivers and all, and generally just have, one or a 400 kilohertz through 1 gigahertz signal generator if I should ever need it, which is a really useful thing to have around. So anyway, having kind of explained that, what was preventing this thing from working? What was causing all the self-tests to fail? Well, the first kind of part of that puzzle was the fact that this thing's self-tests are all done in loopback mode. So basically, internally, it connects like its ports together and uses the signal generator in itself to test its own receiver. So you can kind of see how that can get rather silly, in that if either of those two components isn't working, then the whole thing fails, right? Like in my case, just the generator had failed and the receiver was great, but despite that it still failed all the self-tests because it couldn't excite itself. It couldn't test itself because the generator was out. So what caused the generator to be out? Well, there's a real common problem with these where the OM Philips hybrid amplifier modules go bad. So I had thought this was the case with mine, since I had no output from the signal generator. Or rather, I should say, I thought I had no output. Now, for all I know, one of these could have still been faulty, because I did end up replacing some of them anyway. But what I actually found was that there was some kind of problem with the PLL on board AA3. And the way I found this out, actually, is due to this spectrum analyzer that I acquired only really recently through my work. So I actually didn't have the means to see this particular fault before, in that with this scope here, I couldn't see the fact that the generator was actually outputting a signal, just drastically far off frequency. I would key in, let's say, 10 megahertz, and actually I would get nothing. If I would key in 165 megahertz, for example, I wouldn't be able to see much of anything because this scope doesn't go that high. However, with the spectrum analyzer, what I could see was the fact that at 10 megahertz input on here, I really did get nothing, and we'll get to why that was the case. But at 165 megahertz, I had a carrier at 289 or 285 megahertz, way off frequency. And essentially, what I also saw in there was that the PLL indicator LED was on, telling me that it was unlocked. So, lots of reading later, I got a little bit more meaning to this. Now, hopefully this is helpful to anyone who has a test set like this and is trying to do a repair similar to mine. So having said all that, let's take a look at the service manual for this thing. Now, I realize this is the 2955A and R version, and I actually only have the 2955, but you'll find that it's basically identical. I found everything to be identical in the schematics and test procedures. So what we're interested in is on board AA3. You can kind of see that there. And maybe the next one has a better shot. Yeah, you're looking at the RF synthesizer and oscillator section. So this is the layout here. So if you're looking at the screen of that thing, and you have it flipped upside down and opened up, board AA3 is in this bottom half. And it's in the back, and this is in the very back right. You will find this chip, IC106 and D106, which is actually an LED, a red LED. So what I found when I opened mine up, and I'd punch in, some frequency like 160 megahertz on the dial, or 165, I would get that weird 280 megahertz frequency instead on the spectrum analyzer, and I would see that this diode here would be lit up red. Now that's connected to a pin on this IC. That pin outputs a signal that indicates the locked state of the PLL. And IC106 in this case is the PLL. It's got a phase comparators, dividers, and it's basically a synthesizer chip, right? But you'll find that the loop, filter, amplifier, all that junk are external, which we'll get to. But in any case, it has this very useful red LED output, which was telling me that it wasn't locking, which makes sense since the frequency I was getting out of the device was completely wrong. So following the service manual, I was doing some diagnostic testing, which had me hook up to test point 4. And test point 4 will show you, or rather near it, and on R3, you have the actual control voltage that's coming out of the PLL and going to the VCO, which is also discrete and external. So if you lift this PLD jumper, it actually opens up the PLL feedback, and whatever voltage you apply across this resistor R3 is actually the VCO control voltage. So here's where I found something really interesting. When following the instructions and applying 3 volts to R3, I was able to get the correct frequency to output on my spectrum analyzer out of the generator output, 165 megahertz, which is exactly what the service manual called for. So that was interesting. That indicated to me right away that there was something wrong with this control voltage here, and that's why the PLL wasn't locking, and because the VCO just was going to the wrong frequency. So what causes that? Well, if you look further in the schematics, I think it's on this one. Here we go. This is IC106, the PLL. Let's take a look at the loop, the feedback loop and filter that goes to the VCO. So here it is, the loop amplifier. That is IC107. So, looking at this, putting my probes on to the output pin 5, or what's that? Oh no, my bad, 6. I found a voltage of 23 volts when it should have been 3. So that makes sense. A high voltage to the VCO is going to nail it to its highest frequency. 23 volts is the even slightly higher than it says here. That's the supply rail. That's the maximum it can be. So it's no wonder that it exceeded its frequency. And so knowing that actually explains another thing. I mentioned earlier how I had absolutely no output when I keyed in 10 megahertz. Well, that would be because this device actually uses several different VCOs to generate the signal generator signals, and when you go below, what was it, like 110 megahertz, 111, something like that, it actually uses this secondary mixer to mix down. Now, since this VCO was getting nailed to its maximum frequency, there was actually nothing coming out of that mixer because it was outside the passband of the mixer, so that explains why I never saw that. But in any case, back to the solution here. So once again, looking at pin 6, I had this really high voltage that shouldn't have been there. So I went back and I started testing the phase comparator outputs, PC1 and PC2. How logical were the outputs there? Once again, manually setting that VCO voltage, I played with the frequency by hand and looked at the outputs of these phase comparators, and everything seemed relatively normal there. Those outputs made sense. So then I looked here, and I see this 9-volt rail going through this voltage divider, so it looks like at pin 3 we should have something like 4.5 volts, and then at pin 2 we have, this complicated sum of these two phase comparators. So when I measured this, I found exactly what I'd expect at pin 2, but then pin 3 actually had 0 volts. And now this starts to explain things. This is an inverting op-amp, so we're going to have some gain times the difference between these two pins at the output. And if this is 0, that difference is going to be a lot bigger than it should be if it's 0 instead of 4.5 volts. Which is exactly what I observed. So doing some troubleshooting, started looking at these components. First suspect is this 220 microfarad capacitor. So I went ahead and just pulled that guy out because he's an electrolytic capacitor, and those are notorious for going bad, so I didn't even bother trying to test it. I just said, you're coming right out. So C108 is located right here. This is where that loop amplifier is. This is the PLL. So C108 is right here. So I pulled that out, and what do you know? Lo and behold, now I was reading 5 kiloohms when checking these resistors here, R119 and 117, which are those voltage dividers. Before I was only seeing like 1 kiloohm there as well. So things are starting to make a little more sense. So I went ahead and replaced that capacitor and fired up the machine, got 4.5 volts here, and everything was right as rain. That was all it took. This LED indicator, D106, turned right off, went from red to completely off after a couple seconds of powering the machine on, and I was getting absolutely bang on the correct frequencies and even correct output level for whatever I keyed in to the front here, which is amazing. That fix was way simpler than I had ever hoped it would be, though it took me longer to find than I would have liked. And it was only thanks to having the spectrum analyzer that I found it at all, because I would never have guessed to try to look for a frequency that high. I didn't really have anything that could have tested that high if I wanted to either. So just to demonstrate what all the fuss is about, I'm going to go ahead and hook up this radio to the test set and show you what this thing does. So I'm going to go ahead and power this guy up, and I'm going to take my BNC and hook them in here. So actually, let me start by, well, the frequency's all off anyway. So, now I've got everything connected. I'm going to go ahead and go to the RF generator. I'm going to go to frequency. Actually, I'm going to go to level first, and let's set this to, well, yeah, let's leave it there. Let's go to frequency, set it to 146, 146 megahertz. There we go. We gotta switch this. And now you can hear that tone coming through my radio. So you got it to 146 there. So, you can see here we've got some settings. We've got a modulation that's set to FM right now. So we can go ahead and go back to the RF generator, set the modulation, and since this is a ham radio that's wideband, the deviation should be 5 kilohertz. So let's go ahead and set the level, and we're going to put 5 kilohertz. Now you can see that's a good bit louder. So this is great. Now I can test the sensitivity of the radio. So if I go back to the generator, now I can adjust this level. Right now we're at a negative 100 dBm into the radio. And you can kind of poorly see. Let me turn that down. If you would focus, please. Here we go. You can see my radio still thinks that's full scale, which is good. Negative 100 dBm is a pretty low signal. So let's go back to the generator here, and we'll start using this knob to adjust the level. Okay, so we cut out at negative 121.8 dBm, which isn't too bad. That's pretty respectable for a radio like this. Or at least that's when the squelch cut out, right? So there might still be a little more sensitivity yet if I were to turn the squelch off. Looks like it pops open at like negative 119. But yeah, so that's the first very useful test you can do, is determine the sensitivity of your radio. So that's something I couldn't do before because my generator was out. Well, let's take a look at the other very important feature of this that was actually working when I got it. So let's go to the transmitter test. So now we're going to test the output of this radio into this test set, right? So we're still on the same frequency, 146 megahertz. I'm on medium power, and I'm going to hit the, I'm going to change this to a low pass filter. There we go. We're going to put the scope on, and let's contract this view a little bit. Yeah, here we go, plus minus 6 kilohertz. Let's change this view. Here we go. Now I'm going to key up. And there we go. You can see that I'm putting out about 2.27 watts on the medium power setting. Looks like the Marconi thinks I'm about 73 hertz off frequency, 73 hertz low to be precise, which is pretty good. On the scope here, you can actually see the PL tone, which is 107.1 hertz, as you can see when I stop talking. Very nice. And you can see my total deviation level, which is 4.9, 5.14, yeah, just about 5 kilohertz deviation, which is perfect. So this is, again, just super useful to have as a ham. To think, all this suffering because of this tiny little daggum piece of shit electrolytic capacitor. Yeah. That's all it took. And, yeah, I realize the overview of the features I've given here is pretty brief if you're familiar with this test set. There's actually a lot more that it can do than what I showed, but I figure for the purposes of this video, which has already gone on for too long, kind of gives you the basic idea of how this thing works, and also shows you the dangers of crappy old electrolytic capacitors. They will let you down every single time. Now my cat's decided to say hello. CQ Mushi from Kilowatt X-Ray 4 Tango Hotel. CQ Moosh, hello? Anyway, that's about all I wanted to show y'all. Just to prove that this thing's working and what it's for. So I hope y'all enjoyed that, and maybe if you're also working on a Marconi test set like this that you've picked up for cheap and you want to get it fixed, hopefully this helps you. See you later.